at -1 to 1. And then the -1 ended up converging, and the +1 diverged. Feel good about the 11.9. Stop me if you have questions. And I don't, did we, it's been a while. I got your extra credit papers back, so if you want to see how you did, feel free to come up and look at break. And then those will be points that I add to your final exam. I also passed out, what did I pass out? Oh, we had a review sheet for the midterm that I passed out. I don't think, did we finish it? I think so, we can go over that. And also remind me, I made you another small in-class review sheet for the final. So if you have time today and you want to do it, we can. If not, you can take it home. Well, this is it. This is the last time I stand up in front of you and talk. So Wednesday you've got a test, and then there's no classes until the final. When is the final? Well, next Wednesday, and no classes Monday.
Wait, next Wednesday at what time?
12 to 2.
Wait, do they ever? What happens if they schedule finals against each other?
That's supposed, so the only way that happens is if some teacher doesn't ignore the final exam schedule. So if you've got a final conflicting with that, is talk to that teacher. Well, actually find out if you do, but talk to that teacher and tell him or her that they're doing it wrong. So I'm going to do the square root of 9 plus x minus 3. And I'm going to start with this. The first thing I notice, well, two things. I'll do the minus 3 at the end. That square root of 9 plus x looks a lot like 1 plus x, except for the 9. And we'll factor out that 9. Okay, that looks good. So I'm going to do 1 plus u to the 1/2. Then I'm going to do u equals x over 9. That's 1 plus x over 9 to the 1/2. And then multiply by 3. And this is the same thing as the square root of 3 plus x. And then finally, I'll subtract 3 to get square root of 9. Square root of 9 plus x minus 3. So that's the strategy. Do the 1 plus u to the 1/2 first, make the substitution, multiply by 3, and subtract off. Do you have a conflict? Did you see?
No. I thought, turns out the final video was actually on Tuesday.
Got it. Yeah, sometimes teachers will just schedule their own and not check the schedule. But if we all did it at the right time, we'd never have to do this. 1 plus u to the 1/2. First term is the easiest. What is it? Always 1. Second term is almost as easy. What's the second term for this one going to be? Half of u. And then the next one is going to be a u squared. So 2 factorial on the bottom, matching that to there. I'm going to have 2 factors on top. What's the first factor? And the next factor? Okay, think about this like a start of a factorial. If I want to do 5 factorial, I can start at 5 and go down by 1 for each factor. So this one I start at a half, go down by 1, and stop at 2. Then I've got a u cubed, it's 3 factorial, 3 factors, 1 half, negative 1 half, negative 3 halves, 4 factorial, negative 4th, 1 half, negative 1 half, negative 5 halves, and so on. So Newton thought hard about exactly how you simplify the binomial coefficients, and was able to fill out what should be the missing entries in the table. Try to make this look nicer. So what I did was just multiplied all that stuff out. I made one decision with all the positives and negatives, everything positive or negative. Make sure we're on the same page. For the 5th term, you expect positive or negative? Numerator? Good. Denominator? Right. And u to what power? Good. Yeah, so if you can see that, you should be able to figure out algebraic formula that generates those terms. My idea is I'm going to come up with an expression that when I plug the appropriate n value in to get the right term. So first thing I see is there's an alternator. And that's how I start every alternator. That alternator is positive on the evens and negative on the odds, which is exactly opposite of what I want. So that's how to fix that. Then, it's the bottom, looks like 2 to the n times n factorial. That's a u to the n. And the top's a little bit harder to write. It's the way I think about it is it's like a factorial. But normally factorials go up by 1 each time. These go up by 2. And it's the stopping number is not n. If I were to do 5 factorial, it's 1 times 2 times 3 times 4 times 5. Is this stopping number, it's a little bit harder. So when n equals 3, I want to stop at 3. When n is 4, I want to stop at 5. When n is 5, I want to stop at 7. So, what's the formula that gives me that last factor? It's got to be 2n minus 2. Does that work? 3? Yeah, better be odd. I like it. 2n minus 3. And you see that when I plug n equals 2 into this, I start at 1 and I end at 1. So this formula is only good from 2 to infinity. And then the rest I do by hand. kept this negative on the top, you could have started at n equals 1. Either way is good with that. Okay, according to my plan, what am I going to plug into here? Good, yeah. So remember, to build this guy up, let's first get 1 plus u to the 1/2, got it. Next strategy, or next step is to plug in a u equals x over 9. It's a lot to write here, not very much is going on in each part. And I'm thinking to myself, this is 1 over 9.